When selecting an electrical panel and circuit breaker, cost is a significant factor. This information provides approximate price ranges for 60 amp and 100 amp single-phase main lug only, or MLO, panels and their corresponding circuit breakers. Please note that these prices are estimates and can fluctuate based on your location, the specific retailer, and current availability. Let's examine the component costs. For a 60 amp panel, the Siemens MLO-60 typically costs between $25 and $35. A square D MLO-60 is generally priced from $30 to $40. An Eaton MLO-60 panel usually falls in the $32 to $42 range. Moving on to the circuit breakers, a Siemens Q2-60 60 amp circuit breaker will likely cost between $6 and $8. A square DQ-60 60 amp circuit breaker has an approximate price of $7 to $9. An Eaton BR-60 60 amp circuit breaker tends to cost around $8 to $10. To determine the total cost of a 60 amp panel and breaker combination, let's add the individual prices. A Siemens MLO-60 panel combined with a Siemens Q2-60 breaker will cost approximately $31 to $43. A square D MLO-60 panel paired with a square DQ-60 breaker has an estimated cost of $37 to $49. An Eaton MLO-60 panel combined with an Eaton BR-60 breaker is expected to be in the $40 to $52 range. Now let's consider the 100 amp options. A Siemens MLO-100 panel combined with a Siemens Q2-100 breaker will cost approximately $41 to $53. A square D MLO-100 panel paired with a square DQ-100 breaker has an estimated cost of $47 to $59. An Eaton MLO-100 panel combined with an Eaton BR-100 breaker is expected to be in the $48 to $60 range. Several factors influence the price differences between these brands and models. These include manufacturing costs, materials used, market demand, and retailer markups. It's always recommended to compare prices from multiple suppliers to find the best deal. When installing or replacing an electrical panel, always consult with a qualified electrician to ensure compliance with local electrical codes and safety regulations. This information is for general guidance only and should not be considered a substitute for professional advice. These price ranges are subject to change, so it's essential to verify current pricing with your chosen supplier before making a purchase. Remember that safety is paramount when working with electricity. Always energize circuits before working on any electrical equipment and follow proper safety procedures. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations. Familiarize yourself with relevant sections of the NEC, such as Article 312 regarding cabinets, cutout boxes, and meter socket enclosures, and Article 408 concerning switchboards and panel boards. Understanding the NEC requirements can help ensure a safe and code-compliant installation. Consider factors beyond just the initial cost when selecting an electrical panel and circuit breaker. Evaluate the quality and reputation of the manufacturer, the availability of replacement parts, and the ease of installation. A slightly more expensive panel that offers better reliability and longevity may be a more cost-effective choice in the long run. When comparing circuit breakers, pay attention to their interrupting rating, which indicates the maximum fault current the breaker can safely interrupt. Choose a breaker with an interrupting rating that meets or exceeds the available fault current at the installation location. This information is typically provided on the breaker's label. Another important consideration is the panel's busbar material, which is the conductive component that distributes electricity within the panel. Copper busbars offer better conductivity than aluminum busbars, but they are also more expensive. Aluminum busbars are a common and acceptable choice for many applications, but copper busbars may be preferred for high current or critical applications. Also consider the panel's physical size and layout. Ensure that the panel has enough space for all the required circuit breakers and that the wiring is easily accessible. A well-designed panel will simplify installation and maintenance. When purchasing an electrical panel, check for safety certifications from organizations such as Underwriters Laboratories or UL. These certifications indicate that the panel has been tested and meets recognized safety standards. Look for the UL listing mark on the panel's label. The selection of an appropriate electrical panel and circuit breaker depends on various factors, including the electrical load requirements of the building, the available fault current, and the local electrical codes. Consult with a qualified electrician to determine the best solution for your specific needs. Remember that working with electricity can be dangerous. Always take precautions to protect yourself from electrical shock and fire hazards. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses, and follow all applicable safety procedures. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the installation or repair. The cost of an electrical panel and circuit breaker is only one aspect of the overall cost of an electrical installation. Other costs to consider include wiring, conduit, fittings, and labor. Obtain detailed quotes from multiple contractors to get an accurate estimate of the total cost of the project. When comparing quotes, be sure to ask about the quality of the materials being used and the contractor's experience and qualifications. Choose a contractor who is licensed, insured, and has a good reputation. The NEC requires that all electrical work be performed in a neat and workmanlike manner. This means that wiring must be properly supported, connections must be tight and secure, and all components must be installed according to the manufacturer's instructions. A neat and workmanlike installation will not only look better, but will also be safer and more reliable. Before starting any electrical work, obtain the necessary permits from your local building department. Permits ensure that the work is inspected and meets all applicable codes and regulations. Failure to obtain permits can result in fines and delays. When selecting an electrical panel, consider its future expandability. Choose a panel with enough spare capacity to accommodate future electrical needs. This will save you the cost and hassle of replacing the panel later on. Electrical panels are typically available in a variety of sizes, ranging from small panels for residential applications to large panels for commercial and industrial applications. The size of the panel is determined by the number of circuit breakers it can accommodate. Circuit breakers are rated in amps, which indicates the amount of current they can safely carry. Choose circuit breakers that are appropriate for the circuits they are protecting. Overloaded circuits can cause fires. Electrical panels and circuit breakers are essential components of any electrical system. By understanding the different types of panels and breakers available and by considering the factors discussed above, you can make an informed decision that will ensure a safe and reliable electrical installation. Remember to always consult with a qualified electrician and follow all applicable codes and regulations. When dealing with electrical components, understanding the terminology is crucial. A main lug only, or MLO, panel does not include a main circuit breaker. Instead, it has lugs for connecting the incoming power conductors. This type of panel is typically used as a subpanel fed from a main panel with a main breaker. A main circuit breaker panel, or MCB panel, includes a main circuit breaker that disconnects power to the entire panel. This type of panel is typically used as the main service entrance panel. The choice between an MLO and MCB panel depends on the specific application and local electrical codes. Another important term is short circuit current rating, or SCCR. The SCCR of an electrical panel indicates its ability to withstand a short circuit fault current. The SCCR must be greater than or equal to the available fault current at the panel's location. Selecting a panel with an adequate SCCR is essential for safety. The available fault current is the maximum current that can flow during a short circuit. It is determined by the utility company and depends on the size of the transformer and the impedance of the conductors. A qualified electrician can calculate the available fault current at your location. When installing an electrical panel, be sure to follow the manufacturer's instructions carefully. Improper installation can void the warranty and create a safety hazard. Always use the correct tools and hardware for the job. Do not over-tighten or strip screws. Before connecting any wires to the panel, be sure to turn off the power at the main breaker. Use a voltage tester to verify that the power is off. Label all circuit breakers clearly and accurately. This will make it easier to identify and troubleshoot circuits in the future. Use a permanent marker or label maker to create the labels. Keep a record of the panel's wiring diagram and circuit breaker schedule. This information will be helpful for future maintenance and repairs. Store the record in a safe and accessible location. Regularly inspect the electrical panel for any signs of damage or corrosion. Check for loose wires, cracked insulation, and burned components. If you find any problems, contact a qualified electrician to make the necessary repairs. Never attempt to repair an electrical panel yourself unless you are a qualified electrician. Electrical panels are complex and potentially dangerous devices. Working on them without proper training and experience can be hazardous. When replacing an electrical panel, be sure to dispose of the old panel properly. Contact your local recycling center or waste management company for information on how to dispose of electrical equipment. Do not simply throw the old panel in the trash. Electrical panels contain hazardous materials that can contaminate the environment. Consider energy efficiency when selecting electrical equipment. Choose energy-efficient appliances and lighting fixtures to reduce your energy consumption and save money on your electricity bill. The NEC provides guidelines for energy-efficient electrical installations. When installing new circuits, use appropriately sized conductors. Undersized conductors can overheat and cause fires. The NEC specifies the minimum conductor size for various circuit capacities. Use a wire gauge chart to determine the correct conductor size for your application. When running wires through walls or ceilings, use conduit or cable protectors to protect the wires from damage. This will prevent shorts and ensure the safety of the electrical system. When connecting wires to devices or equipment, use appropriate connectors. Use wire nuts for splicing wires and terminal lugs for connecting wires to terminals. Be sure to tighten the connectors securely. Loose connections can cause arcing and overheating. Grounding is an essential safety feature of any electrical system. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. The NEC requires that all electrical equipment be properly grounded. Use a grounding electrode conductor to connect the grounding system to a grounding electrode, such as a ground rod or water pipe. Surge protection is another important safety feature. Surge protection devices, or SPDs, protect electrical equipment from voltage surges caused by lightning or other electrical disturbances. SPD divert the surge current to ground, preventing damage to sensitive electronic equipment. The NEC requires that SPD be installed in certain locations. Arc fault circuit interrupters, or size, are a type of circuit breaker that protects against arc faults. Arc faults are dangerous electrical conditions that can cause fires. A size detects arc faults and quickly trip the circuit breaker, preventing a fire. The NEC requires that a size be installed in certain locations, such as bedrooms and living rooms. Ground fault circuit interrupters, or GFCIs, are a type of circuit breaker that protects against ground faults. Ground faults occur when current leaks from a circuit to ground. GFCIs detect ground faults and quickly trip the circuit breaker, preventing electrical shock. The NEC requires that GFCIs be installed in certain locations, such as bathrooms and kitchens. When selecting electrical equipment, consider its environmental impact. Choose equipment that is made from recycled materials and is energy efficient. Dispose of old equipment properly to prevent pollution. Electrical safety is everyone's responsibility. Be aware of the hazards of electricity and take precautions to protect yourself and others. Follow all applicable codes and regulations. Consult with a qualified electrician if you have any questions or concerns. Regular maintenance of your electrical system is essential for safety and reliability. Inspect your electrical panel and wiring regularly for any signs of damage or corrosion. Test your GFCIs and size periodically to ensure that they are working properly. Replace any damaged or worn components promptly. A well-maintained electrical system will provide years of safe and reliable service. Understanding the basics of electricity is helpful for anyone who owns or operates electrical equipment. Learn about voltage, current, resistance, and power. Understand the difference between alternating current or AC and direct current or DC. Know how to read an electrical meter and calculate your electricity bill. There are many resources available to help you learn about electricity. Take a class, read a book, or watch a video online. The more you know about electricity, the better equipped you will be to use it safely and efficiently. Electrical codes and regulations are constantly evolving. Stay up to date on the latest changes to the NEC and other applicable codes. This will help you ensure that your electrical installations are safe and compliant. The electrical industry is a dynamic and challenging field. If you are interested in a career in electrical work, consider pursuing an apprenticeship or formal training program. A career in electrical work can be rewarding and fulfilling. You will be able to use your skills and knowledge to help people and make a difference in the world. Remember that electricity is a powerful force that must be treated with respect. By following these guidelines, you can help ensure the safety and reliability of your electrical system. Always consult with a qualified electrician for any electrical work that you are not comfortable performing yourself. It's important to remember to de-energize circuits before working on them, use appropriate personal protective equipment, follow all applicable codes and regulations, and seek professional help when needed. Electrical work should only be performed when you are fully qualified, knowledgeable, and have the proper tools and safety gear to complete the task. The information provided here is merely to provide general information and should not substitute that of a licensed electrician in your area.